So I'll just basically go through another piece that I've written lately. It's basically talking about generative design and metric space analysis. This is basically an interesting experiment which has already been there. Like I've just mimicked existing piece of multi-objective genetic algorithm, which basically lets us explore different configurations of a particular design, and we could select an optimum high performing piece, and then we can just conceptualize and build on top of that particular configuration. So it's been there, like we've like genetic algorithms have like a huge history of they've been using these things for a lot of business problems, be it like logistics or supply chain and all that. But in design, I see that it has been like slowly starting getting the traction of especially when Autodesk have started using these kind of basic configurations, wherein like you can just iterate a lot of hundreds of different of configurations, leveraging the computation that we have as part of the recent advancements that they've made in terms of deep learning and all that. So this use case basically talks about a simple prototype that I've built in space planning. So what I started with is like a simple random plot, and just I'm trying to kind of come up with a configuration which kind is like optimized for certain objectives. So simply we're trying to configure and optimize it for a single objective is very simple. Like let us say if you want a central land to be, so this basically piece is basically considered to be a neighborhood, and what I'm trying to do here is basically simple green spaces that is I need to like kind of put in terms of maximizing the area, and it also needs to be centralized so that every boundary will be having a equal kind of approach towards this. So that was two different objectives that I tried to optimize this basic configuration on. Uh, the way I started this is basically just like a simple CAD plot of the entire boundary. It's a random prototype that I've taken, and so the generative design helps us to integrate and kind of iterate different configurations at real time, and we could actually see the effects and it's basically metrics, right, numbers. So we can actually see what is the configuration of a particular design when it started, and then we could see that progress of how optimized these configurations could get when it comes to the towards the end. That's the advantage of generative design, whereas parametric is basically we've been all trying to do this parametric design wherein you just start with a module and just increase it and in terms of parameterize each and every aspect of it. But generative design is going aggressive in terms of exploring different. Generative design can also take leverage of parametric design, wherein like if you build a parametric model and then you can just run it and simulate it in a particular environment where you run these different configurations and see all the different aspects of how your essential metric is being affected. So just basically about that introduction of generative process. And so what is important here is like to come up with these performance metrics. In the case of what I try to do, I'll basically so this is basically like I told simplicity block wherein I just try to uh, plan it in terms of commercial block and simple green space network, wherein like I wanted to keep a certain percentage of this entire block to be open and green, but also the challenges were to plan the approach, and then there are a lot of metrics that I could come up with. Let us say what the distance between these one of these should be maximized so that you don't end up having everything inside a certain core, so that it will be democratizing enough, like all of them will have the access. And also you need to make sure that it's not like too far from any particular corner, being that kind of affects the travel time and distance. So it's basically an optimization problem. So basically, the way I did this basically using Rhino, I could just uh, simulate this and kind of parameterizes all these simple blocks, and this is a simple road network that I tried to build in. And this entire setup, first I just started with a simple Galapagos So I've taken certain parametrics here, right? Like first is commercial plots. One is the buzz, like it should be it should not create that congestion in terms of the traffic and everything. So the way to that do that is basically increase the distance between these nodes. That could be a simple metric, right? And then the spread, like the total distance between each of the centers would again matter. So I try to maximize that particular part. Road area, so the area between these basic lines, if that could be maximized, then the circulation area is again in turn, will be kind of optimized. So these are some of the metrics that I started with. And using Galapagos, as we all know, it's a being built tool within Rhino, wherein it will help us do this evolutionary solvers by iterating different things. So I just started with this, and this is not like a multi-objective solver. Basically, it does the basic stuff of iterating different things, but uh, uh, basically it would not optimize it for multiple problems. So all I could do it was basically give us certain things for maximizing the area between different configurations, or basically trying to add up these distances. All that mathematical stuff was possible, but it kind of did not give me a complete hand of how to plug in all these different metrics together as a solver, and then I tried multiple times. So now coming to this multi-objective generative algorithm is basically already an existing piece of thing that has been being practiced a lot of in different industries, as I told, like be it logistics or supply chain optimization. But as in design, like it was, I guess, started by people from Autodesk, where they started this using this inside this a simple library that I've called it as Discover. This is basically a simple JSON object that I've tried to input this data into Python, and using a framework called Discover, basically I was able to just iterate this. It does basically the same thing. This Discover framework is by Daniel Nagy, which is, I think, utilized for Autodesk optimization, which I've just taken it the exact same code piece, and I've just tried to use it in my problem. Wherein now, once you start running this, basically what it does is it kind of tries to different come up with different configurations, and each configuration, all these metrics will be like noted inside a particular um, list, wherein that list again will be optimized based on the sorting. Like if I just wanted to maximize certain letters in the area, then that will be that the case will be just taken, and then the second configuration will be built on top of that in order to deal with the next objective. So it's basically an optimization problem, and finally, what it gives is basically, if you run it over, say, let us say some 1,000 to 10,000, the number of configurations you could do is infinite, right? Like you can try with a lot of different configurations, but you can just actually set up a different threshold on which, like, you would say, I would accept this configuration with this kind of threshold, and then you can just choose like the top 10 decisions based on that particular threshold, and you could just then have your human view of deciding which configuration would be better. That's the basic way. And also the advantage of having this multi-objective algorithm put up in Python is basically it will give us the data set, and then this data set can be extremely helpful to understand the configurations, and in terms of how the performance is for across different metrics. So I'll just explain you how I did this. Basically, I've just generated some 5,000 design configurations. So this took a lot of time. Like back then, I just started it in like some my local processor. It almost took like one and a half day for me to like run this completely. And basically, I got a huge list of all these 5,000 line items, and then I just tried to analyze which configuration could be better. Now there could be a human bias. Like I could just say visually this is appealing, then that is like it's also having this high score, but actually there could be a lot of other designs which we might miss visually inspecting, right? So it's the reason why basically this metric space analysis is a very helpful tool, which wherein like you could actually come up with two different metrics at a time together, and you can add different dimensions in terms of it. This is basically a scatter plot, wherein like it would the x-axis you're taking a particular metric, on y-axis a different metric, and you could actually populate all these configurations in terms of how all these are performing. and then maybe you can just choose the optimal one, just like selecting a data point, and you can just once you hover on this, it's interactive graph. So you will get a design configuration for which the things have been optimized, right? And similarly, you can try different cases, and it's basically permutation and combination of what you want to finally take from that design. So this is something which is extremely helpful in terms of making the data driven designs. So what I've observed is basically people would come to the extent of generating all these designs, but the post analysis is not something which is being done. So having that data science background actually helped me to go further and see if what else can be done once you get this data. So the data is the key, right? Like if you have the data, then you can actually extract the most insightful meaning out of that, and which would actually help us build different, be it like different use cases, or also the most optimized one in order to drive that value. So that is something which this metric space analysis is what is capable of. And so finally, once we have all these different configurations tested on different dimensions where it fair to be, finally I could just come up with the optimized solution where it kind of satisfied all the four different metrics that I took, like in terms of maximizing the area between that and all that four stuff. And finally, I just try to make this as a workflow design wherein like be it a simple interior setup, or all the way till like a huge design that could be implemented at a city level or at a design scale. So it's pretty simple. Like the way you can just plug it in and start with deciding what all metrics you want to optimize, and then how you design your data problem, and then finally just run this, optimize it, and analyze it. Finally, you just select some of the possible options which will be bagged with data, and also like like satisfying all the four or five objectives that you started with. So this is how it can be very advantageous for any urban designer or an architect who could make utilize this as a use case.
Yeah, yeah. I really like because it's not very common. I have seen like as part of the generative design workflow, people do this kind of data visualization. At one point, I was thinking, okay, for multi-object optimization, can we do it in Octopus? And but then when you showed the how you can create JSON and then you can plug it into the JavaScript framework, I think that part might not have been possible if we go ahead with that route.
Yes, right. Uh, so the advantage of having, writing this entire from scratch is like you understand it, and you can just prepare a framework which you could utilize it for your next project, or have that, and you'll get to have that control of finite things. So Galapagos and Octopus are great. Like they will help us to initiate and conceptualize certain ideas, but in order to test and actually perform the end-to-end analysis, tools like these frameworks will actually help us. And what it does not give us is basically this final data set wherein you could just play it with different configurations and understand all that stuff. uh, and also like the generative design, the scene here in, at least in India and all the different parts of the country, as we see, is basically like some of the posts that we discussed, like people just start exploring all these different high-end tools without having a practical the use cases. So this I just wanted this to people to understand this, like there's a lot practically materialistically things can be done instead of just coming up with different configurations which are like irrational. I don't say like aesthetically that may be right, and you just want to visualize it and conceptualize that, but having this data backed approach will actually help, and it will actually matter to the the stakeholders who are trying to invest in this particular project.
Yeah, and it's really good that you clarified parametric versus generative because it's not like super clear to many folks that what's the key difference.
Yes. So it's unfortunate state like where we have this two different diversions of like schools of thought, like for generative design, wherein like you end up learning all these high level like Houdini, all those like simulation
True.
softwares, wherein you'll end up like coming up with different visually appealing designs. But practicality, when it comes to practicality, that doesn't help much. Like so all you can do that is like explore a lot of things and basically post some good Instagram pictures, but that is not actually helping the architecture scene and the practice that is uh, in the industry.
Yeah, that's a really good point. Like, the, because of the Instagram, like, people wants to produce cool stuff, and I think that's where the value of this generative design tools come in. So it might be possible, maybe, that sometimes some kind of form enhances the aesthetic as well as the building performance, but you need like data to prove that, okay, if you just do a straight regular form versus this kind of form, it's
Right.
through these results you can see it's improving performance, and that's why it makes sense.
Yes, exactly. So it's basically the same thing like generative design. Or what I mean, as part of this exercise, did is also a generative design. We try to explore different, configurations, but it has been, backed with this algorithm, which kind of optimizes us for certain, measurable metrics instead of just like visually like appealing or all that, like which is rational. Also, the same thing that's happening. Like even if you look at these, right, like so all these complex forms, it is possible, but actually there's a method to these madness, or what you call it, basically trying to optimize this for a particular measurable metric versus like just exploring it visually with trying different rational stuff. So this is how it actually matters.
Yeah, yeah. Like, I think it's important to note uh, the factors when we do this multi-objective, and I think Ladybug provides like daylight factor,
Right.
heating load, cooling load. So that's why multi-objective is important. Like, I can, if I want like good daylight, I can just increase the amount of glazing, but then it comes with increased heating load, increased cooling. Like, so I
Yes.
think
Right.
having that holistic approach is important. That what are different disciplines and aspect will affect just from a single form change or uh, like opening.
Right.
Cool.